So on quiz 11 here, let's see, I gave you this capital F function, capital F of x equals the integral from 0 to 2x of s squared ds. And I wanted you to find f prime, capital F prime. So basically what I need you to calculate is the derivative of an integral, of a definite integral. Right? I need you to derive this guy with respect to x. Right? Because this is a function of x. So you derive both sides with respect to x, but when you take the derivative of a definite integral, the second fundamental theorem of calculus basically says these guys cancel and you plug this in. That's almost right. So the second fundamental theorem of calculus says the derivative of the integral comes from plugging the 2x in. So you'll get this. But what am I missing? What else do you have to take care of? The chain rule. Right? The second fundamental theorem of calculus applies only if you have an x on top. It's usually phrased like this. If you take the derivative with respect to x of an integral from a to x, it's equal to f little f of x. But if you don't have an x here, if you have a more complicated inside function, you have to multiply by the derivative of the inside. So you plug the 2x in and get 2x squared, but times the derivative of 2x, which is 2. So altogether you get 4x squared times 2, which is 8x squared. Damn. You have an inside function here that's not just x. Oh. I guess a lot of people didn't get that one.
Wasn't it just like the example that you did in class, though? There was an example that you did in class that was very similar to it.
But
Clearly it wasn't.
oh, did it have just an x on top, or did it have an x squared? Because that's what the real killer is. Whether this is x or not.
It didn't have the 2. I think it was just an x.
That's the difference. If it were just an x, then you would just plug it in. But if you have anything more complicated than x, you have to multiply by the derivative. What else? Anything else I can answer? You guys trying to do the homework?
I just did the quiz.
The quiz, okay. Excellent. So how would you calculate this indefinite integral? So you could try and distribute it out, but at the end of the day, if you make this 1 over x to the 2/3 plus x to the 1 by distributing, since the plus is on the bottom, there's really nothing else you can do after this. If the plus were on the top, you could separate it. But since the addition's on the bottom, this doesn't get you anywhere. Instead, what's the relationship between 1 plus x to the 1/3 and x to the 2/3?
It's derivative of the outside. The 1 plus 1 x to the 1.
If you take the derivative of 1 plus x to the 1/3, it's going to be some kind of x to the 2/3. And because this x to the 2/3 is in the denominator, this actually works out by letting u equal 1 plus x to the 1/3. Right? Because you know when you derive this, what do you get?
You get 1/3 x to the negative 2/3.
Yeah, 1/3 x to the negative 2/3. Or 1 over 3x to the 2/3. So then if you look in your original integral, you have a u on the bottom, and then this 1 over x to the 2/3 is basically your du. So this relationship between 1 plus x to the 1/3 and 1 over x to the 2/3 is allowing you to do a u substitution.
Is it du or dx?
Dx. So this whole thing here is going to contribute to my du, but I have a 3 on the bottom, so I go ahead and put a 3 on the bottom and fix it up. But then for that to balance out, I need a 3 on the top outside. And then this whole portion here, 1 over 3x to the 2/3 dx, this is equal to du. And then this guy inside here is equal to u. So my integral becomes 3 integral of du, right, all of this is du over u. And actually the main point of section 5.2, right, this was from 5.2. The main point of section 5.2 was to be able to integrate du over u or 1 over u. What's the integral of this? Yeah, so what? Wait, 1 over x. ln. I thought we had something, but it wasn't what I expected. So there's a couple of ways you can write this, but here's what we saw the first time we ever saw this, right? The integral of 1 over x dx is equal to ln of absolute value x plus a constant. Okay. That's because the derivative of ln is 1 over x. So the integral of 1 over x is ln. Right? Derivative goes this way and gives you 1 over x. Integral goes this way and gives you ln. This is the same thing notationally as this, dx over x. So whether the dx is being multiplied like this or the dx is on top, it's the same problem, and that's your answer. And if you have du and u instead, that's just a different variable, but the same formula applies. You'll just change this guy to ln of u. So over here, where I have the integral of du over u, this becomes 3 times ln of absolute value u plus a constant. Or 3 ln of absolute value 1 plus x to the 1/3. Why can't I, by the way, some of you realize this, but for those of you who didn't, why can't I break this up and rewrite this as the integral of u to the -1 and do my power rule? What happens if I try this? Yeah, you get 0 in the denominator if you try to do a power rule here. Right? The power rule for integral says you add 1 and then divide by the result. So if you tried to tell me that this was 3 times u to the -1 plus 1 is 0, then divide by 0? Oh, that's a frowny face. So this doesn't make sense. If it's just u to the first on the bottom, or just x to the first on the bottom, you got to use natural log.